Hey scholar, you are welcome back to another episode of teaching. So today we are going to be looking at a very important concept in vector analysis, which we call the direction cosine. This is a concept that many students find difficult to understand, and even many textbooks do not make justice. That is why we are here. At Class Bridge, we try to simplify this difficult concept as simple as possible. Now, let's get to business. What is direction cosine? We can say direction cosine are the angles which the vector line makes with the positive direction of the coordinate axis, most especially in 3D space. One of the best way to understand this concept is by using diagram. So let's say we have this 3D shape with y-axis, x-axis, and z-axis. Now let's have a position vector moving from the origin to a point A, whose vector components are A, B, and C respectively. Alpha is the angle moving from the vector A to the positive axis of x. Beta is the angle moving from the vector A to the positive axis of y. And also, gamma is the angle moving from the vector A to the positive axis of y. For better understanding, let's look at it in 2D plane, where we have y-axis and x-axis. A and B be the vector component. Also, we have a position vector OA. Angle alpha to the positive axis of x, angle beta to the positive value of y. Then by extension, we have two right angle triangle, OAX and OAY. From our trig ratio, we can deduce that cos alpha is equal to A over the absolute value of vector A. Since cos alpha is adjacent over hypotenuse, and our adjacent is A, and our hypotenuse is the absolute value of vector A. In the same vein, cos beta will be B over the absolute value of vector A. Also, since the vector lines are perpendicular to each other, which means they are orthogonal, we can now say by extension cos gamma is equal to C over the absolute value of vector A, where the magnitude of vector A is given by the square root of A squared plus B squared plus C squared. Let's do a simple naming ceremony. Let's say cos alpha is equal to L, cos beta is equal to M, and cos gamma is equal to N, such that L is equal to A over the magnitude of the vector A. Also, M is equal to B over the magnitude of vector A, and N is equal to C over the magnitude of vector A. Right now, we can solve some examples under direction cosine. And as you can see, we have been able to simplify the concept such that everyone can understand. And we are doing this not just for you to know it alone, but to be able to also teach others. Now, let's see some example. Very good. Now, let's solve this example together. They said, given that vector A is equals to 3i plus 4j plus 12k. First, find the magnitude. Then, we find the direction cosine and angle which the vector makes with the z-axis. Okay, very good. Now, first thing first, we need to understand that this vector A has what we call the component and its unit vector. So this vector A, I can rewrite it as A is equal to AI plus B plus BJ plus CK, right? Where this A, B, and C are what we call the vector component, right? And I, J, and K are what we call the unit vectors. Unit vectors. Very good. Now, we already know that whenever we have a question like this, to find the magnitude is very, very, very simple because we already have the formula, right? Now, to find the magnitude of that vector, we can just say the absolute value of the vector A is equal to the square root of what are the given values? We have 3i plus 4j plus 12k, right? So it means we'll be having 3i all squared plus 4j all squared plus 12k all squared. It's as simple as that. Now, we need to know that when we have I dot I, it is equals to 1. When we have J dot J, right, it is equal to 1. And when we have K times K, right, it is equal to 1. This is what we call the scalar product, right? This is what we call the scalar product, which imply that here we will just be having something like 3 square, because I times I, which is I square, is equals to 1 already, plus 4 square plus 12 squared, right? Very good. 12 squared. Very good. Now, having this now, we'll be having our vector A to be equal to the square root of 3 raised to power 2 is 9 plus 16 plus 144. And all of this should be equal to the square root of 169. And this should be equal to 13. So this is 13 units, right? Which imply that the magnitude of the vector A, the magnitude of our vector A is equals to what? 13 units. It's as simple as that. Now, having this now, we want to look for our direction cosine, right? We want to look for our direction cosine. And we already know that for direction cosine, our L is equal to A over the magnitude of the vector. M is equals to what? B over the magnitude of the vector. And also, N is equals to what? C over the magnitude of the vector also. So, our answer is here already, which implies that our L will just be what? What is our A? That is 3. 3 over what? 13. Can you see? M is equal to what? 4 over 13. And last but not the least, our N will be equals to 12 over 13. It's as simple as that. So, they ask us to look for the last but not the least, they ask us to look for the angle which the vector makes with the z-axis, right? That is also very simple. So you will agree with me that when we are talking about the z-axis, we are talking about n, abi? N, right? Good. So what do? We can now recall that cos gamma is equals to what? N, and our n is equals to what? 12/13, right? Very good. So this is the solution to our question C, right? And if we should find our division here, it is approximately equals to 0.92, right? So which imply that we can now say that cos gamma is equals to what? 0.92, and our gamma will be equals to the cos inverse of what? 0.92, which imply that the angle should be what? 23.6 degree. So it's as simple as that. So you can see that we have been able to find the magnitude of that vector. We have been able to find the direction cosine of the question, and we have been able to find what? The angle which the vector makes to what? To the z axis. So it's as simple as that. So thank you very much, and once again, the aim is for us to learn together and grow together. If you have gained value from this video, consider to like the video, share the video with your friends, and consider subscribing to the channel. Till we meet again next time, stay mathematically active.